Hi guys, the next concept in this three-dimensional geometry is a plane. So plane is determined uniquely if any one of the following is a norm. So we'll see the following points. In that, the first one, the normal to the plane, normal to the plane, and it's a distance from origin is given. So this we'll call it as a equation of a plane, equation of a plane in normal form. So this is what the first point, the normal to the plane. So as you guys know about the normal to the plane, and its a distance is from the origin is given, then we can call it that is nothing but equation of a plane in a normal form. The second one, the plane is nothing but it passes through a point and it is perpendicular to given direction and is perpendicular to given direction. So in this case also we can say that it is a plane. And the last is, if it passes through a three non-collinear points, it passes through three non-collinear points. So as you know that the collinear is nothing but the points will coincide. So here I will consider a 3 points and all the 3 points are non-collinear. It's nothing but different points. They will not coincide. Then there will be a plane will passes. Is nothing but a plane is determined uniquely if any one of the following is a known. Then we can call it that is a plane. So first point in that is the normal to the plane and its a distance from the origin is a given. Then we can call it that is the equation of a plane in a normal form. Or we can say that plane is nothing but it passes through a point and it is perpendicular to the given direction, even though we can call it is a plane. Next is plane is nothing but it passes through three non-collinear points. Then we can call it even that is also a plane. So now today we'll just derive one formula, that is equation of a plane in a normal form. Okay. So for that, equation of a plane in normal form. So we'll just draw the figure for that. Here is the x-axis, y-axis and z-axis. X, y and z. So here I'll just consider 3 different points on each axis and I can call it, so this is the plane. Can we call it this is a plane? Because it passes through 3 different points. It's nothing but 3 non-collinear points. Then we can call it this is a plane. Now within this plane, I'll just consider the end point and it is perpendicular. Next it will passes through the origin. Next this is O and this is again, and this is a point P with the coordinates x, y and z. I can take this OP as a position vector r. Next, this is the distance of ON is a small letter d. Now, with the help of this one, we need to derive the equation of a plane in a normal form. So, I'll just explain the figure. So, here we can consider the plane, that is this whole thing, whose perpendicular distance is from the origin, and you can consider that distance is a small letter d. Next, if ON is a vector, if I take ON is a vector and is normal from the origin, then n cap is a unit normal vector, then I can say that this ON vector can be written as a d with n cap. Next, I can take the point P, it is in the plane with the coordinates x, y, z. Next, this NP is, you just look at the figure, this is the triangle ONP. This PN is perpendicular to ON. You can consider that is a right angle triangle which is perpendicular, right? If the PN and ON are perpendicular, then their dot product is a 0. So in a vector algebra, as we studied that, if two vectors are perpendicular, then their dot product is a 0. So with the help of that definition, I can write that PN vector dot ON vector is equal to 0, and I call it this is 1. So why this dot product is 0 means this PN is perpendicular to ON. So next, here we can write, let R be the position vector, else we can write PN vector as. So if I go with the Pythagoras theorem, because this triangle is a right angle triangle, hypotenuse square which is equal to the sum of the square of other two sides. So is nothing but, I'll just go with PN can be written as ON, PN is nothing but OP, which is equal to PN plus ON. We need a PN, therefore we can write OP minus ON vector. Okay, so now with the help of this one, we can write PN as OP vector minus ON vector. OP is what? It is a position vector. I can write that as a vector R, minus ON is nothing but it is D and N cap. This is what PN vector. Okay. So now you just substitute this PN in a equation 1. That is equation 1 implies PN is nothing but vector R minus D into N cap. It is a dot product, therefore dot. ON is nothing but again D into N cap, which is equal to 0. So now here this D is not equal to 0. Okay, so we know that D is not equal to 0, hence vector R minus D N cap dot N cap is equal to 0 because D is not equal to 0. Okay, now you just multiply dot product vector R dot N cap minus D into N cap dot N cap is equal to 0. I can write this vector R dot N cap minus D is equal to 0 because N dot N is a 1. And so I can write vector R dot n cap, which is equal to d. This is the equation of a plane in a normal form. Is it clear? This is the vector form of equation of the plane. Now with the help of this one, we need to write the Cartesian form of equation of a plane. So for that, so here is, this is vector form of equation of a plane. Now, so if I consider the point P, it is with the coordinates x, y, z, then OP is a position vector. OP is a position vector with a R, and I can write that as xi plus yj plus zk. This is what the vector R. Next I can take n cap. For that, L, M, N are direction cosines. Then unit vector n cap can be written as Li plus Mj plus Nk. So now you just dot product with R and n cap, that is xi plus yj plus zk dot Li plus Mj plus Nk is equal to D. So as you know that in a dot product, I dot I is a 1, j dot j is a 1, even k dot k is 1. Hence, with the help of that one, I can write L into x plus M into y plus N into z, which is equal to D. This is what the equation of the plane in a Cartesian form. Okay, the Cartesian form of equation of a plane in a normal form is Lx plus My plus Nz, where L, M, N are the direction cosines. Okay, so this is the vector form of equation of a plane, and this is the Cartesian form of equation of a plane in a normal form. Okay, so now this is what the derivation about the equation of a plane. So we'll solve the problem based on this derivation in the next class. Okay.